Hello everyone and welcome to yet another webinar session organized by Fogwing team of Actina Computing. So we do really appreciate and thank everyone present here for taking the time and joining us in this webinar session. A quick brief on today's topic, which is how to launch a smart manufacturing solution in AWS under 100 days. So by the end of this webinar, you will gain insights on the Fogwing platform architecture, overview of Fogwing on AWS, and tools tailored for manufacturing. Also, the key milestones and deliverables within the 100-day timeline. So, my name is Bobin, and I'm part of Fogwing's marketing team. So, for those who have been part of a previous webinar, we are glad to have you back. And for those who are like joining us for the first time, I would like to take a moment to provide a brief introduction about us. So we are Factana, an industrial software provider offering Fogwing as a comprehensive platform for smart manufacturing. Okay, so our solutions include asset management, asset maintenance, asset productivity, energy monitoring, quality inspection, and workplace safety. So these solutions are designed specially to transform enterprises into digital factories efficiently. So we have been assisting numerous small, medium, and large enterprises in their journey towards adopting Industry 4.2 and also digitizing their manufacturing operations. With a global presence, we operate in India, Europe, and the USA. So, Mr. Hariharan Ganesh, who is the founder and chief architect of Fogwing, will be presenting this webinar. So, before getting started, a quick note to all. So, if you have any questions or queries, please do not hesitate to ask. You can shoot your questions in the chat box, which will be answered towards the end of this session in the Q&A session. Okay, and also a recorded session of this webinar will be uploaded soon on our YouTube channel. And for those who are like watching the recorded session of this webinar, you can also post your queries or questions in the comment section on our YouTube channel. We will be happy to answer them all. Okay, so without further delaying, let me quickly hand over to Mr. Hari. Over to you, Hari.
Thank you, Baman. Hello, everyone. Good evening. If you're watching later, good morning and good afternoon. So it's exciting to discuss today about how to launch smart manufacturing initiative 100 days, especially in the in the AWS cloud infrastructure. We purposefully designed this solution to make it rapidly adaptable, rapidly deployable, and quickly give some value to the top management on realizing the digital manufacturing or smart manufacturing. Before we go further into smart manufacturing, just to bring all of us into a common understanding about smart manufacturing. What is mean by that? Because there are various terminologies being floating around, like a digital manufacturing, industry 4.2, industry 5.2, smart manufacturing, manufacturing digitalization, and things like that. Intended to improve the manufacturing business, especially operational side of that. How do we streamline the operation? How do we improvise the operation with the help of technology? So in a nutshell, in this, what is smart manufacturing is making allowing deploying technology to identify a way to make a smarter decisions in terms of the operations. So the key value for smart manufacturing is operational excellence. The key output or ROI from smart manufacturing is to achieve the operational excellence. That's the top value expected out of that. By how do we do that? By using technology. When we say technology, by combining the people, the process they already follow, and the technology, the modern technology, combining all together to identify key informations, insights from the day-to-day operations, and then helping the decision makers to have a instant access to the operational data to make a quicker call, high efficient calls or decisions to change the production plan or improvising the quality of improvement or identifying where there is a lean manufacturing aspect of that, 8 ways is taught there, and how do we improvise that? So all of them is part of the value that created by the smart manufacturing. In a very simple word, smart manufacturing solutions helps the operational team to make smarter decisions with the help of the data. So the key is the data, how we gather the data, and how we extract the insightful information from it, and then how we use that information to take some actions. So you know in general, we talked about data, how we can get the data from the machine and things like that, and of course operational improvement and all. But the fundamental difference, from traditional manufacturing, we operate in manufacturing traditionally with paper-based tracking, MIS systems, the MES system in shop floor, and ERP systems in the corporate level. We gather the information over a period and put together all the data and prepare some metrics. And of course, today even top management is looking at the data, and they get the reports from the factory or the sites. So, but how this smart manufacturing is make a difference is that the number one thing is, the data being collected so far is manually by human through log sheet and other sheets and in the factory floor. So we have to digitalize that so that instantly we get the access to the data. So the value of that is to bring the data quickly into the system so that we get a higher visibility in the shop floor. So whatever is happening in the shop floor, we get instant access compared to traditionally, this data will come over the period and they may not know the actual what happened. Only the metrics will show that, oh, this is the OEE or this is the cycle time is happening. And generally, it's could be standard, oh, we are running this cycle time, but really how much efficiently it is running, it's not measured. We just know that, we are our standard cycle time is maybe, 3 minutes per product or 2 minutes per product or something like that. So getting the operational visibility is the key difference, and especially at real time. So the real time data that captured from the machine rather than human, entering into the log sheet manually, and then somebody going and collecting and then feeding into the MA system, and then from MA system they are preparing reports. These data are gathered directly from the machines. So understanding the mission health, the mission functions, machine running time, downtime. So it's in the instant access to those data is possible, and that makes a huge difference from the traditional manufacturing operations to the smart operations. Not just emission data, it's also important to collect the data from the operators or the field workers, and collecting the data from them. Traditionally they submit a log sheet by handwritten, but instead of that, this log sheet have a lot more data in terms of the process data and other data, even including the product shift and information they are capturing there. So we can collect those data from the digital inputs, and that's also very important things because machine data is one side of that, and then operational data is another side of that. The combination of that will give the whole picture of what is happening in the shop floor. So that information accessibility itself is a big difference on that. So collecting the machine data and operational data from the actual team who running the production. And then by providing the digital technology to the operators, we can also improvise the process that we want to follow. Example, in a log sheet today, they are not capturing the data properly because manually they are writing in handwritten, and it is not fully enforced to capture it. So whatever they enter it, that's going into the bunch of log sheets stored in the storage area. But really, when we enforce the digital platform or operation digital tools to them, and then ask them to follow that steps into that gives the enforcement of the process that we wanted to follow to improve the efficiency of the shop floor functions. So that increase the process efficiency with the help of digital tools. By capturing mission data, also improves the understanding about the machine health parameter, running parameter, and then understand how efficiently the machine is operated by the operator, how efficiently the machine is working, and how the availability and all. And based on that, the maintenance and operations can be planned. Manual 90% of the operations are productions are after production, manual checking of quality things are there, and which can be automated with the help of quality control systems using computer vision or other technologies, so that it can improvise the quality aspect of the shop floor operations. So getting a operational visibility is a key difference. Collecting data from the machine and the operators helps to understand how efficiently things are happening, and also enforcing the process into that. Along with that line, the side effect of that, to say the reliability and quality improvement. Overall, altogether, it makes the operational team as well as the top management to make a smart additions. So the key ROI from this smart manufacturing adaptation, or applying the smart manufacturing process into the organization, or initiative into the organization, helps to improve the make a smart additions. That's a key ROI. All other improving the cost cutting, or high productivity, more production, it's all side effects of that. It's all more additional KPIs. So main value here is to make decisions faster, and that decision helps to improvise the systems, process, and people in a holistically. So that's a way that we will look into the value of the smart manufacturing solution, and that's a key deliverables from the smart manufacturing solution standpoint. But when we say smart manufacturing from technical side, oh, we are excited, oh, smart manufacturing side, but there is always a nervous on the from the shop floor. When we talk about new process incoming, new tools are coming, new technologies are coming, and then there is a big questions in the shop floor level. Oh, how this is going to be helpful to that, or how this is make a difference in that. What is that I'm going to get out of that, right? And how this is going to help our life improvement from the operational time standpoint, people standpoint. So so there is always a question on what is the real, how we can achieve the real value of this, the smart manufacturing, because it's not an initiative that something immediately can be enforced to get output from that, from the operations. So very important, we need to set up some expectation, define the principles before we start initiating, they start smart manufacturing operations, or some initiatives at the shop floor level. So number one, most critical, is the people adoptions. 90% of the digitalization projects, especially manufacturing digitalizations, failure because of the lack of adoption at the shop floor level. This is the one that we have seen multiple cases where technology being deployed, but user adoption is really bad. Because of that, the technology also been omitted to be used, and then the ROI is absolutely zero on that. So number one, most critical thing is the people adoption, to understand what level of people capabilities exist in the shop floor level, and how do we make them understand to use this technology, how this technology will help them to improvise their day-to-day life into that. So that education is very, very critical. So adoption is very, very important. How do we enforce this small technology or digital tools usage at the shop floor level is a critical for the success of the smart manufacturing initiative. Second most important thing is having a realistic expectations. There is a lot of buzzwords, there are a lot of KPIs, there are a lot of marketing materials available. Top companies talking about digital manufacturing or smart manufacturing values and all. So because of this hype, the expectation is, oh, if we do this implementation, if we invest in this effort, we are going to be a very big change in our organization. Oh, it's going to be a super duper solution, so that we can improve all our reduce all our expenses. We can make 3 times bigger improvement in the organization and things like that. But in a practical case, these expectations are good to have, but we should set a realistic expectation when it is initial stage of the smart manufacturing. It won't come in day one. When you deploy the technology, the results will not come in day one. The results will come over the period as the practice is, improvising, improving the efficiency of the shop floor. Then only the results will come. So it takes time to realize the bigger value out of that. So initially, the expectation should be realistic, that how and where we can start, how we can incrementally improve it, and how we can realize the value faster than bigger. So biggest real expectations will will make people to upset rather than set the expectation on how gradually this will increase. That's the third point as well. Execute your smart manufacturing initiatives gradually. Don't jump into big bang approach. Don't go into everywhere. Start in a smaller cases and then go into the bigger cases. Identify the key area where you can quickly show the results to the top management and a shop floor team. Then go to the challenging areas into the process. So execute gradually is very, very important. Don't jump into big bang approach. And then so set that itself as a principle. Oh, we are not going to do big bang. We are going to do a gradual implementation. So step by step, department by department, improvising the system. So it's very, very critical on that. Fourth point is efficiency versus speed. So don't rush into deployment. Don't rush into deploying technology into the shop floor. Don't rush into expecting something will happen very fast. No, efficiency is very important than the speed of implementation. So go into go and do that gradually. Yeah, measure the value, improvise the system, and then go to the next step onto that. So efficiency improvisation is important than the speed of results. So go more efficient focused than the speed of implementation or speed of operations. And then continuous improvement. So it's not a one-time practice. Smart manufacturing, as a technology provider, yeah, any provider can bring the technology solution and then they can deploy the technology into that. But this is not going to change everything significantly in day one. So and also it required a continuous improvement in the decision making. So ongoing checkpoints is important to see how people are adopting the technology, whether all of them using the digital tools that we provided or not. How do we enforce them to start using the tools? How do we educate them to do the tools? And then learn from what feedback from the shop floor, and then improvise the system to go to the next level, so that you are not just enforcing something which they cannot easily digest. Also you should improve it in a slow cycle basis. So that's very, very important. So continuous improvement is the key. It's not a one time implementation project. It's a continuous implementation. So you have to plan this ahead, how you are going to improve over the year and over the practice, right? This is all practice. This is smart manufacturing. Is one side is a technology, another side is people and practice. So very, very critical to understand that all three combination is very, very important. Then governance. How do we prepare a team as a smart manufacturing governance team, like IT governance team? It could be a subset of IT OT governance team. So and then see how people are using this technology. Do continuous improvement, enforcing it. If people are not using it, enforcing it. Identify what's the feedback, how we can improve the system. Start practicing it, enforcing the practices. Where there is a gap in adoption, find why this gap is in adoption and how we can make it easy for them to adapt it. So all of them is should be defined as a fundamental principle even before you start your smart manufacturing initiative. So very, very critical to define and understand this before you start, so that you don't have any surprises later point into the practice. So this is not just a technology. This is not just a project. It's a practice. So by digital tools will give only the tools. The practice will make that realization faster. Okay, so then talk about the technologies, right? Generally, if you go and Google it, or if you go and read any smart manufacturing solutions, generally, everywhere you could see the technology talks on that. Like smart manufacturing using industrial IoT, and you need these technologies to do that, achieve it and all. So the key things are IoT is a key fundamental things, because smart manufacturing is all about how do we connect to the machines, how do we get the data. So the foundation is the IoT technology. The advanced analytics is the next level of that, because once you have the data, what do you do with the data, right? So what do you do with the data? How do you identify different key metrics out of that? So that's analytics side of that. So having analytics technology is also a foundation for smart manufacturing solutions. Then going into the AI, cloud technology or cloud computing, enterprise applications, and AR, VR tools, robotics or blockchains. These are all more case basis. So that's why we clearly define it, and not everything for everyone. It's based on, based on the organization, based on the current manufacturing operations, based on what they want to achieve it with the help of smart manufacturing technology or solution, and what they can do faster first than later. Don't jump into digital twins in day one without even connecting to the machines, because you don't have a data to do the digital twins in day one if you don't even connect to the machines. So adapting, just directly jumping into digital twins is going to make the solution fail, because you don't have a data to really understand what happens. Theoretical digital twins will never win. So you need to have a data first. So adapting the technology in a gradually, and as the process is improving, is very critical than in just going big bang and we want to do smart manufacturing with the digital twins and other things day one itself. No, it's not possible. It's not required for everybody. So you have to take a call on for your manufacturing operations, for your day-to-day production operations, for currently what you are practicing in with your data, how what you level of data that you are gathering today, how you are gathering the data today is going to make a difference in your technology adoption. So everything is not for everybody. Go and choose the right technology to start with small, and then scale up from there. Once you have the technology, once you have advanced analytics, once you have AI based predictions, and then you have the cloud computing technologies, then go into next level, thinking about how do we make it automatic robots, robotic models, and then go how we can build the digital twins, how do we bring the supply chain blockchains into that. So it's all of them based on that data that you already gather. Without having a data, going jumping into the technology is going to make more investment, and then realization will be, or ROI will be very, very small on that. So our objective in this webinar is not jumping into everything, hi-fi technologies and talk about that. So we are talking about, how do we achieve smart manufacturing? How do we deploy smart manufacturing practice in the organization, in the manufacturing floor or shop floor, within the 100 days. So we are not going to talk about big bang things and all. So we are going to talk about the fundamental things on that, right? The fundamental things for deploying smart manufacturing is to how do we connect to the mission, how do we get the mission data and operational data, how do we consolidate the data, how do we identify the key informations out of that, how do we present to the decision makers, how to make them to take decisions quickly first, and then how do we deploy the process practices into the digital practice into the system. So how we can enforce the team to start following the practice in terms of workflows, creating, allowing the operators to do certain things as part of their day-to-day reporting and things like that. So the fundamentally, we have to define the architecture on that for basic, or to begin with, what we have to achieve as a foundation layer. So the foundation layer architecture is what we put together here as that, because we want something achieved in 100 days in rapid speed. So the level of the technology or architecture that we are going to deploy, the level 0 is more on machine data. So the machine could be a modern machine with OPC UA connectors, or the legacy machine, fully manual operated, electrical operated machines, no input output ports, no controls, just to go, it's just operated by the shop floor level, which are installed 20 years back or 15 years back, like that. So it doesn't matter, what kind of, machines you have. There are different ways to get the data from the machine, using sensors, controllers, PLCs, and just a simply analog input. So that's a level 1, the level 0, where machine data gathering is critical, and that's going to enforce the process to the operators. So the operators are coming at the level 1, digital data gathering. Machine data could also be part of the digital data, or the operational input, like tablet, providing tablet to the machine operators, providing HMI, connected HMI to the machine operators, or using IoT connectors to connect the data and gather the machine data, and then get the user input from through that. So all of them, it's capturing the operational data, and how do we convert that machine data into operational data into that at the shop floor level. And how do we consolidate that into the centralized data repository is the level 2, where data aggregation is happening. This is not your historian database. This is a centralized data, that repository where all your system data are gathered together in a much flexible, non-structured model, so that you can create a different kind of process to extract different insights out of that. The level 3 is more on the level 3 is more on the process data processing. How do you process the data? What are different KPIs we have to build and present to the top management, or operational management, or GM? How do we present this data? So how we can capture this data, cleanse the process, analyze the data, extract the metrics, KPIs, manufacturing KPIs, and presenting to them. So having this data with the help of the tools like data processing, data streaming, AI analytics, and all, big data analytics, and how do we build all of them together, and then presenting it to them visually to the applications, and how do we apply different workflows through the applications is the level 4 on that. So from 0 to 4, 5 levels are we have foundation layer that required to start getting the data, both operation data and machine data, and making it as a processable data to the top management or mid management aspect of that. So that's the initial foundation layer that required to start the smart management initiative practice. But the same, how do we put that together? The model we have shown, right? How do we put together in the in a AWS infrastructure, right? How do we use different tools from the AWS to do that? But in that case, when smart manufacturing is a very large scope of that. If you try to put together a full architecture for smart manufacturing, there are many use cases are addressed within the smart manufacturing, like machine monitoring, machine downtime monitoring, machine production data, machine quality data, machine usage level, log sheets, tracking, operational data, what the shift is happening, how efficiently happening, cycle time. So there are a lot of data use cases are there within the smart manufacturing aspect. It depends on the organization; these cases will vary, but to just give an idea about how we can build a simple use case in the AWS. This diagram, this architecture diagram and recommendation provided by AWS itself is shows different components we need to be deployed. And if you look at this structure of that, there are many various AWS services are being used, but by looking at the diagram, it shows like there are like IoT services are being used, Lambda functions used, S3 buckets are used for data storage and all. But if we apply simple logic into that, you can categorize that into three as a three basic level, right? One is the data capturing the data from the machines using cloud IoT services, and then streaming the data into the next level of data processing, data storage and processing level, where data are being stored, processed in a hot and cold storage, processed, identify the metrics, KPIs, extracted the data, the KPIs from it, or categorizing the data into more of operational data, operational KPIs versus mission KPIs and things like that. And that is the second stage of that. The third stage is more on visualization standpoint. Now, how do you put together this data into dashboards or be a reporting system so that the reports can be generated faster. Also, then the people in the shop floor and top floor can review this data. So if you take this entire simple architecture of machine monitoring itself, if you put together this architecture in the AWS, there's three major blocks on that, from the data capturing, data processing, and streaming, which is very similar to what we have seen before, right? In the standard architecture, the bottom layer is the data capturing, and the middle layer is the data processing, data streaming, data processing, and then analytics, intelligence development, and then top layer is more visual layer. So that's how the simple use case. But if you try to build this whole solution in the AWS with using different things, it is it's a process. You need to put a time and the effort to build all of these components together to achieve the machine monitoring, machine downtime solutions. Of course, it's a process. It takes time, its own time to realize, and this is where we bring our solution into this to streamline and accelerate in the same AWS with the same AWS services, how we can deploy some solution faster so that we can rapidly build these use cases solve these problems to the top management within the 100 days. And this is where this Fogwing Smart Manufacturing platform for enterprise is coming into picture, because this has a lot more modules. We provide everything in the AWS as part of our rapid deployment architecture model. So if you are first time, if you are looking at this our platform solution, I just want to give you quick things and what is there in the platform. So the whole platform is called Fogwing Smart Manufacturing. Within that, there are many different operational application or softwares are there, software applications are there. But the foundation, the right side, you can see that the foundation is this. So from the shop floor, we gather the data through IoT data. We focus on usage data, downtime data, production data, location data, energy data. We capture all this data with the help of the device that we provide, and this data stream into the platform architecture, foundation layer on that. The foundation layer is the two layer, IoT layer, and then the intelligence layer. On top of that, we have the applications. So the data stream through the layer, as you have seen that in the AWS itself, right? The data capturing, data processing, and then visualization. The same layer, you can see that from the top to bottom on this. On the top layer is very important, because this is where we are bringing a more value to our customers, because we provide the applications that build based on this data, and instantly it gives access to the team to start using these applications and applying the workflows along with the data intelligence and things like that. So it gives a inside visibility as well as helps to apply the workflows. So example, our enterprise asset management helps to define the list of organizational missions and their life cycle. Maintenance management software help them to apply their maintenance practice and planning and executing the maintenance operations to avoid the downtime and improve the work availability of the assets. The asset performance management helps to monitor the process data, example, mission running time, mission downtime, mission health parameters, vibration, temperature, speed, all these parameters, capturing them and processing it, so that it helps to understand how the missions are being operated. And then the production monitoring helps to understand how the product being produced, how efficiently the product being produced, how efficiently the missions are operated, how much quantity is produced, how much quantity is rejected out of that, how much quality solutions are coming out, I mean quality of issues are coming out, what are the different type of mission downtime and all. So all of them is coming as part of the productivity monitoring as well as the quality inspection. And then the energy monitoring gives a different perspective of how the energy being used across different things, and what are the different consumptions level, and how the trend of the energy between last month, this month, and usage level and things like that. The last one is the workplace safety, which is more relevant to the environmental safety standpoint. So there are different module applications are there and modules within that, and depends on where the customer wants to start it, because this is all part of our smart manufacturing solution. But as I said in the beginning of this this session, that we have to start in one and then grow from there. We cannot go on big bang approach, but all of them are connected systems. So it depends on the customer environment, depends on their how they are their priorities, what they are doing, how they are operating, depends on the mission types, mission of the today's problem that we are facing in the with the production operations. We recommend the customer to start with any one of the one of the module as an initial step within that, and then over the period we will enhance that experience into other holistic approach of that. Example, we may start with simple production monitoring, or we may start with the mission maintenance aspect of that. Depends on the challenges that they are facing. If it is a older factory with a lot of manual maintenance, then we would recommend to go for maintenance, because more maintenance issues are happening in the older factories. The modern factories, we will go with the production monitoring, because the machines may not, life is much earlier, so younger, so they may not have that much maintenance operations, but they want a visibility into the production monitoring. So depends on that, we will start as one phase and then go from there. So if you take our solution itself, because we are going to talk about how to deploy the solution to AWS, okay, how faster we can deploy the solution to the AWS. So if you look at into the platform architecture, because understanding the architecture is very important before you deploy this into the AWS. So if you look at the fundamental architecture of the platform, there are two major blocks are there. One is the IoT layer, another one is the industrial AI layer. So both of them are the foundation layer for our application and its workflows. So the core services that we have created within the platform are IoT connectivity services, data aggregation, data integrity checks, validating the data checks, data streaming to the applications, trend of the data, to understand the energy monitoring and similar use cases, manufacturing KPIs like OE metrics, cycle time metrics, downtime metrics. So those kind of metric calculations, predicting the predictive metrics for predictive maintenance or predictive machine production, and forcing things, quality inspection, using computer vision models, ML AI models. For computer using computer vision AI models, we can build the quality solutions. Application workflows built within the application. We also deploy integrated with the Gen AI co-pilots for intelligent information. So all of this services or components that we are using within the platform as a general. But now when we apply this into the AWS infrastructure, so we to realize the 100 days 100 days of realization from smart manufacturing standpoint, we build the foundation layer. We start with the core services that require to start the smart manufacturing solution rapidly within the AWS infrastructure. So we leverage the AWS IoT services, core services, for building a connectivity between the machines, and then with the help of our devices. So we leverage the IoT services. We use Lambda functions for data cleansing, data aggregations, data stream processing standpoint, and workflow related things, streaming the data in different things. And we use Kinesis also. Some cases depends on the type of data that we are streaming. And then we use the centralized enterprise data lake, which built on A3 bucket, S3 buckets, and then we use that data. So because this is very critical portion, we capture the data, we stream the data, where we store the data into the S3 bucket. From there, we take that data into the our intelligence layers to processing it. So this data can also be used by the enterprise IT team to take this data, and then they can build the other IT operational systems or related intelligence they need with the help of ERP system and things like that. Suppose the customer having a SAP system and SAP BTP technologies, and they can leverage this data that we capture and aggregate into staging or the data lake. They can take this data and processing IT operation related data, because our smart manufacturing solution is pretty much focused on the shop floor level. We don't focus on the IT side of intelligence and building, because that's a different cases that require a lot of ERP data together. So we facilitate this with the help of our platform. So we focus on the shop floor level. So that's how we build this in a rapid speed. And then CloudFront for application access, ML services for predictions, and then using ML services for predictions, and some of the intelligence data capturing and insights development and all. And then we also use the APIs for the external facing gateways and all. So we use the core of 6 services within AWS as a pre-build within our platform in the AWS version. So it's ready to deploy to the AWS infrastructure as soon as we get engaged with the customer. So this is all ready to build, so we can start with it. On top of that, we can use other AWS services as per the AWS recommendation to use the services for enhancing this manufacturing solutions into the digital twin or other capabilities that we want to build after 100 days. So as we are moving towards other solutions, we can use other services. The core services are already pre-built within the architecture, within our platform architecture itself, the AWS version of the solution. So what the customer will get when we go for Fogwing Smart Manufacturing. Number one, you would have seen that before. To building this solution within AWS require a lot of services, development and comprehensive workflow development within that, using different services. And then of course, building the visual application is a complete development area where the workflow may not be. So it may be good fit for using the raw AWS services to build a solution from scratch for a visibility standpoint. But when we use a Fogwing Smart Manufacturing solution, it comes with apps, pre-built apps, and then the devices. So it get with the same solution, we can deploy it, but with the scale that we can enhance it further into that, and then rapidly we can adapt it. So the key benefits are the pre-built applications. So we have a pre-built applications, the visualization layers, the workflow layers are pre-built within the application. So we take the data and map to the application. So applications start functioning, in day one. So depends on the use case. We go by application, the implementation. We don't go every application in day one. As per the principles, start easy and go scale up from there. So we go with priority application first, and then we add additional application because all are co-build with that. So each and every one is application is connected in the same platform architecture. So that's the biggest value to achieve it. Second biggest benefit for customer is this we host this in the customer's environment, customer's AWS host by managed by our team. So because we manage it, the whole architecture, we are able to manage it. So it's part of our services. So we manage the platform, but it's on the customer cloud hosted environment. And it's ready to deploy. So we rapidly deploy our solution to the customer's cloud, and we build the data lake repository or we leverage existing data lake that the customer, we already have that. So we use that data lake. All we need is S3 buckets to stream the data and store the data into that. We help the customer on the implementation. As part of the implementation, we take care of all the technology part of that for customer. So we make it seamlessly for customer to adopt this technology and not worrying about how do we build this implementation solution and building a IT team to implement all of that. So because our solution is a pre-built solution comes with the flexibility to use the AWS services. And we bring the industrial grade IoT device, and industry grade tablets, because IoT devices are for machine data capturing, and then tablets that we are bringing, the tablet based apps that we are bringing in for the digital input from the operations. So as we looked at in the beginning, the two critical data that we have to capture from the shop floor or the machine data, as well as the operators inputs, the log sheets that being practiced right now, and we have to digitalize that. So both of them we capture it with the help of our tools and technology. And we provide a different role access. We provide a plant level access, maintenance team separate access, and electrical team, engineering team separate access, and we provide access to the operators separately for their metrics. We display the cockpit, displays in the shop floor level for visibility of the production of performance. And customer can use the different roles. They can define different roles, access different things, unlimited users access, and all. We also manage multi-site, so it's not just a one plant that we have to deploy. One instance can operate with multiple sites, so multiple plant. So customer can use one instance across all the plants depending on the size and volume of the environment. So we can scale up from there. And we also releasing ongoing software upgrades to the customer. So as we improvise the software as per the our release cycle, product release cycle, we improvise the software. We introduce new features to the customer, and we offer free discovery consulting. How they can start. If customer not sure about where to start and how to start and all, we help them to understand. By studying their plant, and we by studying the plant and identifying the gaps and how we can start quickly with the smart manufacturing solution for our customers. So we provide all of them as part of our offering in the AWS. So the question still remains same, right? How we are going to achieve this in 100 days. What we are doing in 100 days, right? What is it? How is it possible in 100 days? Is just installation? No, not really. So we put together a plan here. This is the plan that we have. So we call this model as a PCC model. Preparation, connect, and configure. With 100 days, there is no development, or most likely there will not be any development. The very important thing is start adapting the technology or process day one, and then scale up from there. Learn from it and then scale up from there. So we start with the operation data gathering. We understand what data being captured today in today's manual entries, how they are capturing the data, what are different informations like a log sheet and all. We gather the data, and then we prepare the site-wise uniformity. So because different multi-sites environment, like a different plant and all, how do we capture the data and how do we consolidate the data so that we can bring a standard practice across all the plants, as long as the productions are similar. If the productions are vary, then we have to bring little differences, but as long as the productions are, we try to uniform it. So data, capturing the existing practice of data and then how do we identify this uniqueness of the data, and how do we map this data into our existing platform architecture. That's the key activity that we do in 100 days. So then, mapping this data into the IoT data. So if we capture the machine data, operator data, all this data captured from the machine, and today whatever data they're capturing, whatever information that we can capture from the machines, we create a mapping to that so that we don't change the application layer. Application layer is a standard, but the data layer is where we create a mapping. So this is a major exercise we do that in this 90 day, 90, 100 days deployment. So data mapping, we prepare it. While preparing the data mapping, we prepare the environment settings also. Environmental settings like, configuring AWS and configuring our basic services. How do we deploy that, and how do we configure it and all in the customer accounts. So once after this mapping and environment settings are done, then we do the mapping. Based on the mapping, the devices are configured and we deploy the devices into that. So for the initial scope of the work, very initial scope of the work, we deploy the IoT devices based on where we want to start with. So if it is a mission monitoring aspect of that, we can deploy IoT devices and tablets. If it is a just asset monitoring aspect of that, we deploy only IoT devices. We don't deploy tablets. There is no need of that. So it depends on that. We take the case on that. So we configure the device, we deploy the device, we configure the cloud application to the device mapping, and then the cloud data mapping, we do that, and then we roll out the application, first application into the within the 100 days. Once we roll out the application, we provided on-site training to the team who start using these technologies, right? So it's very, very important. Adoption is very, very important. That we have to start from the initial 90, 100 days itself. So we provide on-site training to the people on how they use this technology, where to look at, what to look at, and how things and all. We handhold them to guide them for the another 100 days period to make sure they are all started using it, and then we go live into that. This is the first 90 days. We will rapidly achieve this, and then based on the learning in this 100 days, we apply the learnings into the subsequent phases of the implementation, and then from there we will do that. So within the first 100 days, we will make one portion of the entire plant, one portion of the operation, start using the digital technologies, and then start showing to other departments on how this technology is helpful to them. And that's the biggest value that we provide within the 100 days of that. And that makes the entire implementation adoption much faster, because once one department started using the technology, then it's easy to convince other departments to start using this digital technology, and then start showing the value to the top management. This is the way that we need to drive it. We cannot go to all missions, deploying all missions and connecting all missions. It will not go anywhere. So we need to start with the departmental or case basis, use case basis. Depends on where you want to start, who you want to address first, and that's how we need to start within the 100 days of period. But in the whole implementation, right? So if you take the entire implementation, okay, in a smart manufacturing, it's a process, and it should be practiced, and it has to go through certain life cycle, right? And we need to start with somewhere, and we need to go somewhere, right? We looked at only 100 days, after engagement, 100 days, how we can make it realize. But this picture gives you the whole implementation cycle. So typically we start at the discovery plant operation study. That's what we did, we do in the initial phase of that. We discover the plant, we identify the plant, and we study the plant missions, and we understand how and things are current practice in plant level. And we identify the gaps, we identify the way where we can apply the digital technologies rapidly, faster, and we can make it use it. That's the first step. Second step is define the roadmap. How do we go about multi-sites, multiple plant? How do we build the uniform implementation model and things like that? Third step is the complete digitalization implementation. This is where the 90 100 days practice will come. The third stage is where the 100 days practice will come, so that we will start realizing it. As soon as it's done, then we go for training and communication, then proactive support while the implementation is going on, and incrementally to other sites, other departments. The continuous support to the customer feedback loops will helps to improvise the system over the period, and then ongoing support that we provided. So this is the whole life of how they will go through end to end of the solution implementation and ongoing service to the customer. So one of the classic case we started is this practice, this solution deployment for an US based production food production company, specialized in making specialty products for their customers in across the US region. And the one of the critical challenge for them is the because they operate 24 by 7 production operations with the 3 shifts, and different teams are coming at a different time, and there are a lot of downtime happening in the night hours, which management people are available to look into the root cause, and the data entry are inaccurate. So there was a lot of lack of visibility, lack of data capturing, uncertainty in the night shifts, and then sometimes daytime also uncertainty in the machine downtime. All of them was the customers' issues, and they want to have a they want to start with the production monitoring first, and then they want to go with other solutions and all. So we started with the production monitoring as a key solution delivery to the customer as a first pay 100 days, realization within 100 days. In fact, surprisingly, we have deployed the solution within 60-65 days itself for the customer, because that level of the simplicity that we followed in the deployment model. And we start with one particular unit, 3 24 by 7 3 shifts coverage within our solution, because our applications are pretty much mapped with the data that we already capture, mapped with the existing data model that we already followed for the missions. So we capture the missions, we deploy our devices along with the digital data capturing to the customer place with the tablets and the IoT devices. So IoT device capturing the mission running time, downtime, and process parameters, the performance parameters, and then digital input tools used to by the operators to feed when there is a downtime, the digital tablet triggering the alert, asking the operators the root cause of the downtime, and then providing reason for that, and capturing some of the key process information that they do manual quality checks and all. So we captured that using the application that we provided as part of the digital operator inputs. And with the help of that combination of the tools, we capture all the data. We are able to gather the production visibility, production information, runtime, cycle time, downtime, mission downtime, mission conditions. The key, because they are making seasonal cookies and other things and all. So there is a specific production parameters they have to follow, like heating, and the floor thickness, and then the moisture level and things like that. So we capture all of them, and they show that to them. The result of that, they got that even though machines are operated by 24/7, and they're not the shop floor management as well as top floor team available all time, and they could see that what happened in the night, and when happened it have happened, and how the production happened, how much quantity being produced, how much is packaged, how much is inventory level captured, how much is the downtime, how much is the cycle time is improving, how much they are lagging behind that, and all the visibility is giving. And then using that, they had to improvise the training and the operational side of that. So that's resulted in a high visibility into asset operations, production visibility, reliability has been increased, especially production reliability has been increased. Planning and execution has increased 85%, because they are able to understand how things are working when they do a different type of cookies and those when they productionate, how and when they should plan it ahead and prepare it. They reduce the waiting time for the production operations, waiting time for the raw materials and things like that. So that helps them a lot in overall operational efficiency and visibility into that. With that, I would like to conclude, and then I am looking forward to answer if you have any question. Hope this presentation helps you to understand how quickly we can, start deploying smart manufacturing practice with the help of the technology that we are providing with the partnership with the AWS.
Thank you, Hari, for the deep insights. So looks like we have a few questions lined up. I'll just read one by them. So on to the first question. How does deploying fogging on AWS helps in reducing operational costs while increasing efficiency?
I think the very key thing is following deployment is the uh, time to realization. Okay, so rapid time that we realizing it. So we the initial 100 days what we try to achieve is is not a full scale or full blown investment into the smart contract. The investment itself is the kind of a MEP investment into that. Because that's a practice that we need to do that. So that's a 100 days deployment. So the MEP in itself, the values will be higher because you can see that, very quickly deploy, we can deploy it, pre-built solutions. So, and also, it's very critical to identify the ROI is depends on, what you are addressing it. ROI is not just a technology, how quickly you can deploy the technology or how much low cost you can deploy the technology. ROI is all about, what case that you are addressing and what is the significance of that particular case. What is the current, loss on, because if you don't have this technology or solution in place, what is the today's loss on that? So if you have that data, and then, you can, you based on that data, you can apply that technology and then start measuring how much you are measurable ROI you will get it. Otherwise, it's a theoretical ROI only. So measurable ROI you can get it. So it's based on the case that you are addressing it. And Fogwing will definitely, we don't just go by, deploy everything into that. We go by, identifying what is the critical thing that we can address, which one we can take it first, smarter, easier, and then how much bigger the ROI value that it can generate. We provide that ROI metrics to the customer upfront so that, they understand how this is going to work, and then we will work on that. So that's how, we commit into that solution. That's a benefit to the customer as well.
Okay, thank you, Hari. On to the next question. How easy it is to get started with Fogwing Smart Manufacturing on AWS?
So the idea itself to make it easy. So the idea itself, the way that we build the solution itself is to make it easy. So as we said, 100 days is a goal. 100 days is a goal. So anything we start with 100 days. Okay? 100 days is a goal, and within 100 days we have to achieve all of this. So we build these solutions, pre-build these solutions, which are just installable, most likely installable. Of course, there are some configuration we have to do that specific to the account and specific to the settings, and those things, we will take care of that as part of the installation. So typically, the installation itself will take 15 days time period is what we calculated for deploying the fundamental solution into that. So the installation standpoint, so it's very fast. We can we can deploy it because it's all done by us, and we know how to configure it in the AWS. All we ask customer is the providing access to the AWS infrastructure that they have, and then provisioning the services that we need, and then we can start deploying into that. So it is it should not take much time. And most important point is the data mapping that we do. That's a critical part, because installing our software and our platform, configuring that in the AWS is pretty straightforward installation procedure for us, for our cloud team. But mapping the data that we capture from the shop floor to that is the is a critical part of that, and that might take, depends on the time. That's why we say that 100 days of deliverables. So we take time to understand things properly, and then we map it, and that might take some time, depends on how much we are getting input from the shop floor and how much data is captured by the shop floor today, and how we can streamline that into the platform.
Okay, thank you, Hari. So we have one more question. So how can manufacturers ensure that their workforce is prepared to adapt smart manufacturing technologies?
So very, very important question. So as I in the beginning, as I told, adaptability is one of the biggest challenge when there is absolutely no digital practice in place at the shop floor level, and then suddenly going and deploying digital solution, asking them to start using the tools is very, very difficult for them to start using the tools without they understand the importance of that. So adaptability is the biggest challenge. This is why we start understand people focused deployment solution that focus on people than the technology. So this is why we initially I said don't go by technology, go by the people, and what is the biggest problem that you have to solve first, and how easily, quickly you can solve that problem. So as part of this, we do two major things. We provide of course we provide ongoing training. Also, we part of the governance team that we recommend customer to form, and then we monitor the governance practice, and then we help the customer to to start making things easier for the operational team to use it. So training and governance are two critical practice or team that we should form as part of the smart initiatives. And then ongoing basis they have to put the effort. So it's not like you can just create a team for a project period of 6 months or 8 months or 1 year, depends on the company and depends on scale. And then after that you can wind up that. It should be ongoing team and it should be ongoing exercise, because people will keep changing. So you have to have a continuous training programs to make sure everybody start adapting the tools. And then you have to have a governance also in place to enforce it on a continuous basis. So these are two critical things for the for adoption. And that is the biggest I would say time and effort that we need to put it into the into make this practice successful.
Thank you, Hari. So that was all the questions we had, and thank you once again, Hari, for answering all the questions. I hope it was helpful for all those who have asked and for others as well. I think now it's time to wind up the webinar session. So, as previously stated, we will be uploading the recorded session of this webinar to our Fogwing YouTube channel. So, therefore, you can visit our YouTube channel to watch this webinar and also our past webinars as well. And for those who are interested in gaining any further insights into IoT, Industry 4.0, smart factories, we encourage you to explore our blog section at www.fogwing.io/blogs. Additionally, if you are seeking any collaboration opportunities, please do not hesitate to contact us at sales@fogwing.com. And thank you once again, everybody, for participating in this session and making it a success. We eagerly anticipate connecting with you in our next webinar. Stay tuned and have a wonderful day. Bye.